All right, let's get started. We were just waiting for you two to get started. How's everyone doing? Good? All right, let's start. Okay, so lecture, I am going to finish Module 1 today. So Module 1 was our biggest module. It was on relational databases, and we're going to conclude that today. Next week, we're going to have a midterm, but the week after that, we're going to start with Module 2, which is going to be mostly what you do in a... We'll talk about sorting, we'll talk about asymptotic analysis, and we'll give you some information about data structures and algorithms. UQ zone. So please set up your UQ zone if you haven't done so already. I know that few people are having trouble doing that. Can you just raise your hand if you're having trouble? If you're having trouble creating a zone. So few people are having trouble. I'm guessing it might be because you registered late in the course. Did you register late? Yes, no, no? So if it says the quota is exceeding, it's either because you have another zone, that you've created another zone somehow, because the quota is 1 per user, or that you registered late and you're not in their system. Regardless of the reason, there's an email underneath that says email this e@help. Please email that e@help. On the same page you get the error, you get an email. Email them, let them know you're in this course, and let them know that this is your user ID, and hopefully they can get back to you soon. Additional exercises. So sample solution to questions on functional dependencies and normalizations have been added. I've also added both the questions and the solutions for SQL questions. I usually post the solutions later to give you some time to do it on your own. But given that there's a midterm next week, I've given the sample solutions as well, so you can kind of check what you're doing right or whether it's right or wrong. Project. So guys, quiet down, please. Okay, so project proposals have been graded and have been released. You should be able to see them on Blackboard. Nick and Anna will be meeting with you to discuss your projects today. Essentially, the proposal was only 10% of the project grade, right? And the main aim is to give you some early feedback. Really, it's less about the grade of what you got. Most of you did really well, and that's fantastic. But it's more about an opportunity to get some early feedback. And essentially, we want to make sure that the scope of your project is reasonable. It's not too large, it's not too small. So that's what Anna and Nick will be giving you some feedback on. Please do take that feedback into consideration before you submit the second part of the project, which is going to be on specifications. Right? So it's more than okay to take whatever feedback that they have, and you change your ER diagrams or the scope of your project based on this feedback for the second submission, which is coming up in a few weeks. And I cannot encourage you enough to start with the implementation early. Right? While the implementation is not really part of the first or the second submission, make sure you actually start the implementation early, because that's going to be the most tricky part. Any questions about the projects? Okay. Midterm. So midterm is going to be held next week during our normal lecture time, so this time next week. I have booked another room. That's the room, and we're going to split you into these two rooms. I will send out an email with instructions of who's going to be in this room and who's going to be in the other room. I had booked a large room that we could all go to, and it held 250 people, and that was great. We were all going to go into this big room. Unfortunately, they took it away because they needed it for a bigger event. So now we're just going to have 2 rooms of this size, and I'm just going to split you into the 2 rooms. I haven't seen the other room yet, so I'm going to check out how many it actually seats and how many chairs there are, and then I'll just send an email on which room you're going to be in. But that's the room, 47A 249. You may bring 1 page of double-sided A4 notes with you. So this is not a memorization course. You're more than welcome to bring a 1-page double-sided A4 notes. You're also more than welcome to share these on Ripple. So if you think you've got the best cheat sheet, share it with others so other people can benefit from it as well. And you can see what other people as well, so you can also benefit from what other people have. Make sure you have your UQ ID with you for the exams. We will be checking IDs, so make sure you have it with you. And I'm going to try two-stage exam. Has anyone written a two-stage exam? No. No one? So they're less common at UQ. I used to do them quite significantly at the University of British Columbia where I was lecturing before. Two-stage exams can only help you, right? So they're a way to help you learn more and get a higher grade. This is how two-stage exams work. There's a first stage, which is essentially what all the exams are like. The first stage is going to be individually done. You're going to have 10 minutes of reading time, and then you're going to have 90 minutes of writing time for the first stage. That's generally what the exam is like. Then we're going to have a second stage where you're going to get into groups of 3s or 4s. You're more than welcome to go back to your project groups or just make another group, because it can be a group of 4. And then you are going to take 45 minutes and you're going to write the same exam. But this time, the 4 of you are going to hand in one exam between the 4 of you. Right? And this is to make some learning happen right after you've done it on your own, so that you discuss it with other people, and the 4 of you agree on one response per question, and that's the one you're going to put in. Your exam grade, by all means, your exam grade is going to be the max of what you do on your own, or 85% from your individual plus 15% from the group. Right? So it can only help you. If you do poorly as a group, you'll be given what you had as an individual. But if you do better as a group, with most people tend to do better as a group, then that could help you by 15% in your exam. Okay? Any questions?
Will we be getting any kind of like appendix of the code from SQL?
No. What do you mean appendix?
So it's like, will we get a sheet of code and what it means?
No. So you have one A4 page to bring yourself, okay. So you can add whatever you want there. Any other questions? So the exam starts 12 sharp. When the lecture is meant to start. We want to make sure that we give you the maximum amount of time. So if you have to leave the previous lecture a little early, by all means. Any other questions? Okay, why are you all speaking to one another? Yes? You don't need to specify your groups right now. Correct. So the entire Module 1 is the scope of the exam, including everything we do today.
And for the content, the first stage is just the first stage is more similar to our sample, or both are kind of the same as?
Say that again?
So because you post 4 sample exam, right?
Yeah.
So the first stage will be similar to the second?
So the first stage and the second stage is the same exam. You will rewrite the same exam together.
What? It's the same question?
It's the same questions, right? It is, the learning is how you've thought about it individually and how you can now put things together. So the second stage is an exact copy of the first stage.
So when we do the second stage, we need to turn in the first stage first.
Okay, quiet down, please. So we collect the first stage. Guys, quiet down. We collect the first stage. You're going to be in 2 rooms. You all come back here, and then we distribute the second stage. Right? So you can't go back and change what you did individually. We'll collect that in. Yeah, and then here.
When we do the second stage, we're going to do it in here or?
In here. So essentially, we'll take the time of the lecture, the official time of 12 to 2 to do the first one. Then we'll wait for everyone to get here, and then we'll do the second stage during the general tutorial time, 2 to 3.
And can we kind of have like draft paper during first stage and then take the draft paper out?
You think you're going to forget to then write it again?
Yeah.
You could. Let me think about it. I mean, you have your note, right? You have a one so that you can take. It'd be unlikely that you'll find time to do that, because you'll be writing the exam the entire time.
But it's like 90 minutes in the first stage, but the same thing, only we have like 45 minutes.
Yeah, but so I've done two-stage exams 20 times or so. Like the second time, you don't need to think about it, right? You've answered it once. So 45 minutes is more than enough to answer it again. Okay, let's start. So if you want to know more about two-stage exams and its benefits, just Google two-stage exams and you find more about what it is and why it's useful for your learning as well. All right, so I'm going to quickly go through what we've done in SQL so far, and please remain quiet, and then we're going to get to where we ended up last week. Okay, so essentially, this is our things that we're going through in this SQL module. We started by talking about data definition language, DDL, in which you create tables, you enforce referential integrity. So we had undelete, cascade, or restrict. We talked about altering tables, and we talked about dropping tables. Then we talked about basic SQL queries in the data manipulation language, DML, which had select, insert, update, and delete. In our select basic SQL, we have select from where, and this is our to-go-to for our basic SQL queries. We talked about some selection and projection examples. We talked about distinction and how you can add distinct to get rid of duplications. We talked about selection and projection, so things that need a selection and projection at the same time. We talked about joins, which allows you to take information from multiple tables and you join it together in the from part, and then you have some join conditions in your where part. We talked about still joins. We talked about renaming attributes, and we talked about ordering tuples where you can do order by. We talked about set operations, union, intersection, and differences, and how you can take that from set theory and how you can apply it here in SQL. We talked about two things being union compatible in order for you to be able to do the union, the intersection, or the difference. We talked about how you can do union, how you can do intersect. Unfortunately, intersect, we talked about it not being implemented in MySQL. We did this trick that you can do an intersect with getting two instances of the tables. We talked about except, and we said, except this is not implemented. You can do it with nested queries, but we haven't talked about nested queries. We'll use a majority of our time today to talk about nested queries. So we'll see how we can use nested queries to do except. Then we talked about aggregation, how you might want to use some aggregation functions in your SQL queries to return aggregated results. Then we talked about group by that allows you to group rows together and then report aggregated results on top of these groups. And then, so these are grouping examples, grouping conditions. Then we talked about the having clause, where the having clause was the sort of conditions you can add on top of your groups. So the where clause is where you add conditions about each individual row, and then the having clause is where you add conditions that you want to be satisfied in your groups. And that is where we kind of left it last week. Are there any questions before we start today's lecture on content from this week? Okay, let's start with a question on REPL. So this is still lecture 4 in class activities, and 1, 2, 3, 4, 5, 6, question 7. It's actually pretty tricky. Give it some thought. So this tip might also help you. You can think of an arc as being a flight, and the query is asking for 2 hop trips. That might also help you. Yes, so this is arc. Yeah, so that's the table name, arc. Feel free to discuss it with a neighbor. Okay, so pay close attention to what you're grouping by. Group by a1.x and a2.y. And your where clause is on a1.y and a2.x. Okay, 20 more seconds. Okay, so all of the above it is, and it is the most popular answer, but we've got people responding the other ones too. What are we doing here? So the condition is that a1.y equals a2.x. So if you think of this numbers as destinations or locations, right? So you're in location 1. This is a plane that takes you to location 2. Then you can take another plane from location 2 to location 3. And then you can look at how many ways you can go from location 1 to location 3. And that group by is grouping by things that allow you to take that 2-hop plane. Right? So 1, 3, 2 means that it's possible to go from 1 to 3 in 2 different ways with 2 hops. And one of them is to go from 1 to 2, then from 2 to 3. And the other is to go from this 1 to 2 to this 2 to 3. 4 to 6. So from 4 to 2 with 2 hops, there's 6 ways. 3 ways to do 4, 1. And there are 2 ways to do 1, 2. Therefore, there's 6 ways to do this. And all of these are possible. So all of the above are right. Any questions? Okay. So another question. Okay, so this one shouldn't take as much time. Let's give it another 15 seconds. Okay, so A it is. Most of you going for that. Count B also, I can see why you might have gone for count B, because you've got B. Why would you do count B? But essentially, this is in the having clause, right? In the having clause, you can either talk about things which are in your group by without an aggregation form. So about B and E, given that they're in your group by and everything within a group will have the same value in the B, in attributes B or E, you can talk about them either in without aggregation or with aggregation. But for things that are not in your group by, you can only talk about those in aggregation form. Why? Because you have different things within that group that will have different A's, right? So it doesn't make sense to talk about the A of an individual one where they're going to have different A's in that group. Yeah, so the having clause is on conditions on your groups, right? So that part we know. So if the having clause is based on conditions on your groups, you can talk about things within your groups, like attribute B and E, both in terms of without an aggregate function and with an aggregate function. Because things within the same group will have the same B attribute and the E attribute. But for things which are not in your group by, like A, the things within the same group will have different A's. So you can't talk about a value for A in your having clause, but you can only talk about average or aggregated values of A in the having clause. All right, let's do one more grouping example. Just as a reminder to refresh your memories from last week, I want you to write a query that will find the enrollment of the smallest college with enrollments larger than 10,000 for each state with at least 2 colleges that have enrollment of higher than 10,000. So if you're lost, where would you start? I would start by just writing select from where group by having, right? Because you know that's the template you're going to have. And then you kind of look at that query and determine how each part of that is going to contribute to your select from where group by and having. Which tables do you need? College. What are you grouping on? State. Your where condition is that you want enrollment to be higher than 10,000. And you want the state, and you want minimum enrollment. Now, there's one thing here which might not always be the case. The way that this is going to be looked at is that when you do your where, first of all, your where condition is going to be to be used in order to filter the table, right? So if this is the entire table, once you get the where clause in, some of these rows may disappear because they're no longer part of that where clause, right? So that happens first. Then you're going to group by. So you've removed some of these rows. Now you're going to do your group by. So now a bunch of these are going to go in the same row to give you one row. Now, in this example, my condition on my groups does not require any of the rows that were filtered out in my where clause, right? Because my having clause says also I want things with at least 2 colleges of enrollment which is higher than 10,000. Now, if I wanted for each state with at least 2 colleges of any enrollment without that 10,000 there, that would have been a more complicated query to write, and we'll come back to that. But right now we're just saying having count star of bigger than 1, because the condition of my having clause is already the same as the condition of my where clause. Right? I'm looking at the same set of states. Essentially, I just want to know, once I put things in groups, when I do my group by, I only want to return groups that have more than one thing in that group. Right, so have that in mind as the next example we do is going to be a bit more tricky.
Can you just, you said a second ago, you said there was an alternate request for data was more complicated than this one. Can you just?
So if the query was without that parentheses at the end, which says for each state with at least 2 colleges of enrollment higher than 10,000, if you take that of enrollment of 10,000, then that will be a more complicated query to write. Because then you're looking for each state with at least 2 colleges, not necessarily higher than, with larger than 10,000 enrollment, which might have been a row that you deleted before because of your where clause. So we'll come back to that example soon. All right, we're going to talk about nested queries. Let's start with a motivating example. Let's say you want to find IDs and names of stars who've been in a movie with ID 28. This is how you would write it, right? So you would look at your movie stars and stars in table, you join them on the star ID, and you look for things where the movie ID was 28. Now, if I want to ask you about IDs and names of stars who haven't been in movie with ID 28, can you write it like that? Talk it over with your neighbors. Convince them whether you think this is right or wrong. Okay, given that I have a big cross on it in my pre-lecture notes, it's pretty obvious it's wrong. But maybe convince them why you think it's wrong. All right, does anyone want to explain why they think this is wrong?
If someone is in movie ID 28 and also in movie ID 28.
Thank you. So this, I want to find IDs and names of those who have not been in movie with ID 28. This is returning those that have been in a movie other than 28. So if you have a person that have been in movie ID 28 and they have been in another movie as well, they will be returned by this query. Because there will be another ID, movie ID 29, let's say, that have also been in 29, and that's going to find a movie which is not 28 that they've been in, 29, and it's going to return them. Right? So this is returning something a little different to what I asked for. If you have people that have been both in movie ID 28 as well as another movie, it will be returned by this, but that's not what I want. So to get what I want, we're going to look at nested queries and see how we can use nested queries for that. Okay, so we're going to look at concepts of nested subqueries. Then we're going to look at correlated and non-correlated variants. Then we're going to look at the operators that we have in nested queries. Then we're going to look at subqueries versus set operations and joins, which one's better. And then finally, we're going to look at division. So what is nested query? A nested query, often termed subquery, is a query that appears within another query. How cool is that? You've got a query, you've got another one inside it. The nested can be inside the where clause, or it could be part of the select clause. It could actually be part of the from as well. It's less common, but you can have it to be part of the from clause as well. And it can also happen inside an insert, update, or delete statement too. Nesting can occur at multiple levels. So that means you can have a nested part in the where clause as well as a nested part in the having clause. Nested queries are useful for expressing queries where data must be fetched and used in a comparison condition. Right? So whenever you want a value, an aggregate value, a set of values from another table to make a decision here, it's good to use nested queries. Syntax of nested queries is going to be select from where. You can have the expression not in or in. You can have the comparison operators any or all that we're going to talk about, or not exist or exist. And then you're going to have another select from where inside it. There are two variants of subqueries. We've got non-correlated nested queries, and we've got correlated nested queries. In the non-correlated variant, results are returned from an inner query to the outer clause, inside out. The outer query takes action based on the results of the inner query. Let's see an example. So this is the example we have. Let's say you want to find IDs and names of stars who've been in movie with ID 28. I can write a query that says select star IDs from star in where movie ID is 28. So that is going to give me the star IDs of those that have been in movie 28. And then I'm going to have an outer query that is going to say look and see and find those that are inside this set of values. Now I've got in here, and I can just as easily use not in here, and it will be finding IDs and names of stars who have not been in movie 28. So the not in version becomes much easier to write if you use nested queries versus what we had before. But essentially this is how this would operate. It first is going to look at the inner query, and it's going to find IDs of those that have been in ID 28. So that's star ID to 1026 and 1027. And essentially, this is then like saying, select m.starId and mname from movie star, where m.starId in that or that. Right? You're looking for those that their star ID is either 1026 or 1027. Now here, I can do this inside out, meaning I can look at the inner query first, compute that. That's not going to change. That's always going to be the same thing. And then based on this, I'm going to compute the results of my outer query. Essentially, there's no dependency between the inner query and the outer query. I can compute the inner query without any interference from the outer query. If you want to think of this in terms of functions, this is a function that doesn't have any parameters, right? Essentially, every time you look at this function, it's going to return the same thing, 1026 and 1027. It doesn't have any involvement from the outer query. How is it different in correlated nested queries? Correlated subqueries have conditions in their where clause that references some attributes of a relation declared in the outer query. The outer SQL statement provides the values of the inner subquery to use it in its evaluation. And the subquery is evaluated once for each combination of tuples in the outer query. Let's see an example. So let's say I want to find for each college, check if there's another college in the same state. So I'm returning colleges such that there is another college within the same state. Right? So we're going to come back to this where exists. So we'll talk more about that later. But I'm looking for college C1 where exists another college where C2.state equals C1.state, and the name of the two are different. Right? So I'm finding another college in the same state where the name of the two are different, and those are the things I want to return. Now, how is this different to what we had before? I've got college C1 in my outer query, and I'm referencing C1 within my inner query. Right? My inner query can no longer be computed without any relation to the outer query. It's now relying on the outer query to give it a value for C1.state. If you have a correlated query like this one, essentially it is going to go through line by line of the outer query, and for each line it's going to compute what's going to happen inside. So first of all, it's going to look at Stanford. So currently C1.state is going to be California, CA. Now, it's going to say if currently C1.state is California, can we find another college within California such that the name of the two are different? And essentially, when you go through the first two lines, and you're going to do this for every line, right? So you're going to go through each line, you're going to keep doing this, and you're going to compute the result for each time you go through this, and you're going to add that to your results. The important part is that the non-correlated version, you do inside out, you compute the inner one first and then you do the outer one. In the correlated queries, you need to go through this line by line from your outer query because there's a relation with the inner query that you need to consider.
Sorry, just how you brought this in today. Should Berkeley and Stanford be around the other one?
I was thinking that. Let me just take a closer look. Yes. Because when you hear, it should add Berkeley, and when you hear, it should add Stanford. Okay, so I can't change it here, but I will change it in the slides before I post it. Any questions?
So why only two values in the result?
So when you get to MIT, right,
Okay, so
there's no other college where the state is going to be the same and the name is going to be different. If I take out this condition, where C2.name is different to C1.name, what do you expect to see here? All of them, right? Because then for each one it's going to be true that C2 is also going to find exactly the same thing, which is happening in the other one. Okay, so let's look at the types of operators you can use in nested queries. So essentially you have two types of operators. Operators that return a set and operators that return a single value. Operators that return a set are going to be used with not in or any or all. Subqueries that return a single value are going to be expressions that we're going to compute using some aggregated functions. So let's start by looking at things that return a set. Expression and attribute list in the select clause must have the same domain. So your inner query is going to return a set of values, and you're going to check whether the value you're looking for is within that array of values or not. So it's like a membership check, right? You're checking whether, and this is kind of like this example with it here. Where this is returning a set of values, this is returning a set of values, and then you're in the second part checking the membership. You're checking whether the movie star is going to be within the set or not. So a set is being returned, and then you're doing some sort of membership checking in terms of what was being returned. You can use any or all for that, or you can use in or not in for that, and we'll see examples of both of those. So in and not in, as a operator that returns a set, the inner clause is going to return a set of values. It's important to note that the inner query is going to be a relation that is returning one column. You can't have a table being returned, right? You're not going to have more than one column being returned because you expect it to be a set of values, not a table. Yeah.
One question related to the correlated queries.
Yeah.
Does it mean if we don't use the alias,
You can't.
then they are not correlated?
For a correlated query, you have to use alias because you're going to have two versions of the same, right? You're going to have C1 and C2 because there's going to be a correlation between them.
I mean, when you write the inner query, if you rename the college to different names, are the inner query and outer query still?
So when you've got correlation, you're going to have a table or an alias here, like C1, that was introduced in your outer query, not here. That's what's making it correlated, right?
I mean, if at the inner query, if you change the C1 to be like call it C3, and you compare C2 and C3 instead of compare C2 and C1, do they still correlate?
So if I change it to C3.state,
Yeah.
you mean?
Yeah.
Then you're just going to get an error because C3 is not defined.
No. If you select star from college C2,
Yeah.
comma college C3, and then you compare with C2 and C3.
Okay, so don't have a nested query. Just have C2 and C3 in the same place,
Yeah.
right? Would that give you the same results?
Yeah.
Yeah, so you can write it like that. It will no longer be a nested query.
Oh, so that's what I mean. If you don't have the name related, they are not related to the query.
Yeah, so you can rewrite that without correlation and multiple versions of the same instance. So C2 and C3. We had done that before in the intersect example that we did, where we took two instances of the same value. Okay, so in, not in is one operator that you can use. The other operator you can use is any and all. let's say you want to find movies that were made after Fargo. You can have an inner query that's going to say, select year for movie where title equals Fargo. That's going to give you a set of values of the years of the Fargos. If there's only one movie Fargo, you're going to get one value here. If there's more than one, you're going to get multiple values here. And then you can say, select star from movie where year is bigger than any of the things in that set, or all of the things in that set. If there's one thing in that set, then the any and the all will be similar. If there's more than one thing in that set, let's say there are two movies in where the title Fargo, then if you use any, it's going to return things that's bigger than any of those. And if you use all, it's going to return things that are bigger than all of those. So if you have two movies, one's in 1980 and the other's in 1990, if you use any, it's going to return things which are after 1980 because that's any of them. And if you use all, it's only going to return things which happened after 1990. Because it needs to be bigger than both of them, both 1980 and 1990. With your any and all, you can also use operators such as smaller, bigger, equal sign, smaller or greater. All these different combinations will be used with your any and all as well, the mathematical operations.
What happens if the inner query has select, which is different than the title?
You get a, so this and this need to be compatible. Right? Because you want this to be of the same type of that. Just like how we had union compatible, where you could only union things that were of the same type, the domain of those need to be the same for this to make sense. Okay, now we talked about how you can write things with in or not in. And we also talked about any or all. And there's some equivalence there, right? And some people find it easier to think about the in version of these queries. And some people find it easier to think about the any version of these queries. So for example, you want to find IDs and names of stars who have been in movie with ID 28. You can write it like that, where this is in that, or where movie star equals to anything within that. Both of those will give you the same results. These two are the same. You can also have equivalence between not in and not equal to all. So you can also write that as movie stars that have not been in movie with ID 28 as m.star ID not in these, or being different to all of these. Right? So essentially this is a set in both of these, and in both versions it's going to be not equal to all of them, and not in that way. You might find one easier to think about compared to the other. However, not in and not equal to all are equivalent, but not in and not equal to any are not equivalent. And if you just want to see that, let's say you've got a set of 30K, 32K, and 37K. Not in means not 30K, and not 32K, and not 37K. Whereas not equal to any means not 30K or not 32K. And essentially this is always going to return true. So these two are not equivalent. And this is just logic, we're looking at. Any questions? All right, let's do a question. to see if you can find an English interpretation of what that query means. Okay, if you're not already doing so, please feel free to talk it over with your team. Alright, so all of the above is the right answer. What is the query saying in English? What are we looking for? Which team scored the least amount of runs on a particular day? Right, so we're looking for team day pairs such that the team scored the minimum number of runs in that day. How are we looking for that? We're looking for select team day, where runs is smaller or equal to all of those where the day is the same one. Right, so it's a correlated query because you've got S1 here as well, S1.day equals S2.day. So for each day, you're looking inside and you're looking for all the runs for that day. And if it's the smallest of all, smaller or equal to that, you're returning that. So this is going to return Carp and Sunday. Both of these are the minimum for Sunday, and this is the minimum for Monday. What would you get if you changed that smaller or equal to smaller? If you use smaller, then you want the run to be smaller than everything which is in that list. What would you get? C? Monday? E. You'll get E. Because even with 0, 0 is going to be returned return as part of that select runs, right? And you want it to be smaller than all of those, and it's never going to happen. So it's going to return nothing, empty.
In that command, if you don't have that keyword all, does it mean that will return all the list? It returns each list.
If I don't have or, which or?
The where runs not bigger than all. Yeah, the all. Yes, the all.
So if I don't have this all, so what happens if I have any?
If you don't have,
Anything here?
yeah.
It's a syntax error. You need to have an operator between your nested query, right? So the two things you can have is either any or all after a mathematical operation, or in, not in, without anything.
So we will have the same answer if we change it all to any.
No. So what would it mean if you change it to any? I have a question coming up on any.
So in here the indentation still doesn't matter. It's the parentheses that matters, right?
So this operation without an any or all is wrong. You'll get a syntax.
No, I'm saying the indentation.
The indentation doesn't matter.
So it's the parentheses that
Yeah.
indicates the nested query.
It depends on the system. Sometimes you can have it without the parentheses and it should work as well. But some of these are not in the standard SQL. It's
Okay. How does it tell where the nested query starts and where it ends?
so based on the syntax, it's expecting another query at here.
Okay.
Right? So after a mathematical operation all, it's expecting another query. All right, why don't we take a quick break? We've got quite a lot to cover, maybe 5 minutes. Hey.
Chat before we start about because my writer's cramp, setting up a special examination. So I got some feedback from the examination section, and they lined up a time to do it.
Yeah.
That was before the complexity that was introduced that you talked about this morning, because they were going to start me about 12:15. They've given me nominally extra time, apart from this access or issue of computer plus write. That's the main issue I had. I didn't really need the extra time.
Yeah.
But they were going to start me about 12:15. So nominally I'm going to have a bit of a mismatch. I mean, it sounds like it's going to be very complex. Is it the end of the world? I mean, not
So
the end
if
of the
you
world.
don't write
if I
it,
just sit-
then you just write your individual, right?
Okay.
The exam grade was essentially the max of the two anyway.
So I'll live with that. I think I'll be just living with the result of the individual, which is fine. I'll live with that.
Sure, I mean, if you don't get here in time, you don't get here in time.
Yes.
There is still, how long are you going to write the exam for?
Well, see, this is the thing. So I must admit, I'd communicated 2 hours because that's what I thought the original.
That's what it says, right?
Because it's strange. So they don't know.
All right. So, is this on? Okay. So just another clarification on this. So how does this work, right? This is a correlated query, so you're going to go through each line. The first line is going to be this. You're going to check whether the runs in this line, which is 4, is going to be smaller or equal to all of this, where this is going to look at all the days where the day is similar, so all the Sundays. So whenever it's a Sunday, it's going to look at the number of runs. So that's 9, that's 2, that's 2, that's 4. And it's going to look at all of these, and then it's going to check whether 4 is smaller or equal to all of those. Given that that is not the case for 4, so 4 is not smaller or equal to 2, therefore the first line is not going to be returned. Right? You do that for each of the lines, and the 3 that I've highlighted are the only ones where that is going to get satisfied, and those are the 3 that will be returned. Yep. Okay. So subqueries that return a value. So far, we've looked at subqueries where the inner query is returning a set of values, and then you're checking or you're doing some sort of membership checking, right? It could also be the case that the inner query is going to return just one value. So for example, here, the subquery could be that select max year from movies. It's going to give you the max year, and then you're going to say where year equals that max thing. So it's no longer a set of things that are being returned, because if it was a set, this would not have made sense for me to say where year equals a set of values. Right? So that is just one value, and I'm checking whether year equals that one single value that is being returned. Okay, so here's an example. This is the one that I promised we'll come back to. This is the one we did before. You find the enrollment of the smallest college with enrollments larger than 10,000 for each state with at least 2 colleges of enrollment higher than 10,000. This time, I want you to write this query where the condition is for each state with, that's not the one I promised, that's the next slide. This one is you want to find the states with average enrollment higher than the average enrollment across all colleges. And think about a nested query and how we can write this. Okay, so if you have it in front of you, that doesn't mean you have to copy what's in front of you. You can still think about it. So what is my returning condition on the states, right? We're looking for states with average enrollment higher than the average enrollment across all of the colleges. So first of all, I need to know what the average enrollment across all the colleges are, right? So that is here. Select average enrollment from colleges. This is going to give me a number. That's the average. And then my having condition is that I want the average enrollment for that state to be bigger than the average enrollment for all colleges. Any questions?
And what would happen if you remove the mean from select part? So mean.
So if I remove that, you'll just get that. So the select is just reporting back, right? Right now it's reporting the state and the min enrollment. If you take out that, this is what you should get. Or at least that's what I think you should get. We can check it. Token mismatch. So let's first see if this works. So that's what we get. And if we do that and take out that, Any other questions? Okay, this is the query I had promised. Give it a go. So essentially you're expecting the having clause to be different compared to the top one, right? Okay, so as we discussed, in the top version, given that the where clause and the having clause had agreement on that condition, that you wanted only enrollment of higher than 10,000, you could have just looked at count star and look at each group and see which groups have more than one member in them and return those. In the bottom one, the where clause and the having clause, the condition doesn't match anymore. Therefore, you're just going to write a inner query here, which is going to count from college C2, where C1.state equals C2.state, and you want those where that is bigger than 1. So here your nested clause is returning a number, and it's part of the having clause. Sorry? So you want this to be greater than 1. So you want 2 or more to be here. Now again, I encourage you to write a lot of SQL queries, because seeing SQL is much easier, reading SQL is much easier than writing SQL.
How come you don't have a bit stipulating that the college names can be the same on the inner query?
So the question is, why don't I have a part where it says the colleges are not the same name? Find enrollments college for each state with at least 2 colleges. So
Does this look at a college, like one row, is it one college whose enrollment is greater than 10,000?
So you want at least 2 colleges, and even without that name being different, like you won't get, that will only give you 1, right? So C1.state equals C2.state for the same college, that's going to give you size of 1. You need to have a different one to be returning more than 2. So I think, and you can check that, but I think it will give you the right answer both with and without having that in. And if you add it in, it will not take away. If you add it in, it's when you have 2 different things, it's only going to return 1 row because now they're different. So that wouldn't work. So this is the right way to write it. If you write it like that, this needs to be, I think, smaller than 0.
So this is for our for certain state, there's only one count 1. And one which does not display error.
If it's 1, so if this returns 1, that row will not be added. Because you're only looking for things which are bigger than 1. So if it returns 1 for a particular state, that will not be included. Okay, so using the exist function. The exist function tests for the existence or non-existence of data that meets the criteria of the subquery. So you're going to have select from where, and then you're going to have exists or not exists a subquery. Now, there's 2 things that can happen. When you say where exists, if the subquery evaluates to true, meaning at least 1 row is being returned. So if at least 1 row is being returned in that subquery, it's going to satisfy exists, and it's going to return true. So if where exists subquery evaluates to true if the results of the correlated subquery is not empty, at least one, and it has at least 1 tuple. And where none exists evaluates to true if the results of the correlation subquery returns an empty set, i.e. nothing is there. Let's do an example. So let's say you want to find movies that were the only movie of the year. So if you want to find movies that were the only movie of the year, you can say select star from M1, where not exists, select star from M2, where M1 and M2 are in the same year, but they're different IDs. Right? So that would mean it's the only one if there doesn't exist another movie which is in the same year. So movie M1 is the only movie of the year where not exists another movie where the year is the same but the IDs are different. And similarly, if you want to find movies that were not the only movie of the year, you can write select star from movie M1 where exists another movie where it's in the same year but the IDs are different. So examples of where exists and where not exists. Okay, so this is a detail not necessarily going to come in handy a lot, but subqueries cannot include the order by clause. The optional distinct keyword may effectively order the results of a subquery since most systems eliminate duplicates by first ordering the results. So when you use distinct, it's going to get rid of duplicates. How does it know if it has duplicates? Most systems will order it, and then based on the order, if 2 things are similar, it's going to duplicate, it's going to delete one of them. So you can use distinct, and most of the time that will order things for you, but the database management system does not guarantee that. So you can kind of count on it, but it's not 100%. All right, so we've talked about subqueries, we've talked about set operations, and we've talked about joins. And there are queries that you can write in all 3 of these versions. So we're going to do a quick comparison of subqueries versus set operations versus joins to see what we see. Let's go back to this example. Find IDs of stars who've been in movies in 1944 and 1974. So on the top you can see the intersect, the set operation version. Here you can see the join version, and here you can see the nested version. The nested version says select star IDs from movie star in where movie ID equals that, and it's also in, and you've got a nested query to say the other one. Right? So that should hold, and also that should hold. But that other one using a nested query. Let's do the OR version. The OR version, this is just going to be the union. This is going to be the join version where the year is either 1944 or 1974. And here instead of and, now you've got an OR in your nested query version. So there are queries that essentially you can write in all three ways. You can use a join, you can use operations, set operations, or you can use nested queries. In such cases, at least as far as this course goes, and as far as our database management system is concerned, we're not really going to worry about optimization. We don't, as long as it works, we'll let the database management system worry about which one's more optimized. So we can write it. The not in version, you can't write with a join, and we talked about that. You can use set operations to write it with except, but except is not part of MySQL. So you couldn't actually run that. If you want to use except and run it on MySQL, you can use a nested query to run it. And you can say you want those that were in 1944 and not in 1974. Right? So this not in is essentially now an easy way to write that except using nested queries. Nested queries are very powerful. Okay, let's do some more examples. So I want you to think about this example, find IDs and names of students, applying to CS, and I want you to find it using both joins and nested queries. Okay, so here's the nested query version, and here's the join version. Okay, so let's take the nested query version. Request failed. Okay, so using the nested version, I'm going to get 1, 2, 3, 4, 5 rows being returned. And these are the IDs and these are the names. And note that we've got 2 Craigs, but different IDs. Right, so 2 Craigs are being returned, but these are 2 different people. Okay, now let's use the join version. Same results. All is good. Any questions? Can you change where SID in to where exists? Where exists? No. So if you change it to where exists, this is going to look at you select SID from apply where major equals CS, and this is never going to be empty, right? Because this is always going to return a student ID. So where exists, if you want to check how you're thinking about it, where exists is always correlated. That something from the top is correlated with the where exists at the bottom. Good question. Any other questions? These two are returning exactly the same thing. One is using a nested query to find the IDs of those that have applied for CS and then looking inside that. This one is joining the two and then looking for those that are major in CS. So why am I using this thing? What happens if you don't use this thing? So now you've got 2 Helens, but these are not 2 different Helens, right? This is the same person. Oh, because the first one, that's actually a good question. The first one is going to go through each row one by one, right? So you're not going to get the same person happening multiple times because you're checking each one, one by one. Whereas the join, Helen is coming up twice because they've had 2 applications to CS. Okay, so here's a more tricky question. It looks innocent and very similar like the previous one. So this time you just want to find the names of students that have applied to CS without their IDs. Okay, so from the nested side, essentially I've just dropped the ID, right? The rest is the same. Now I'm going to run that. And I'm going to get the same results as before without the ID. Note I still got 2 Craigs, right? And we know these are 2 different people. What is the issue when I run it with join? So when I run it, so essentially, I'm getting 2 Helens and 2 Craigs. The two Helens are the same person, the 2 Craigs are not. So both with and without distinct, this will be wrong. If I don't use distinct, this is what I get, which is wrong. And with distinct, I'm going to lose one of the Craigs, which is also wrong. Now, you might think, I mean, it's the name. Who cares whether you get 2 Craigs or 1 Craig, right? I mean, but essentially, the problem is that what you want to get, you can't get with this join here. And why is duplicates important? Let's think about that I want to compute the GPA instead of just returning their names, right? So let's say that I want to find the GPA of CAS applicants, and now I'm just changing that to select their GPA. And now it is important, right? Because now, if I lose one of the Craigs, then the GPA is no longer correct. And if I use 2 Helens, it's still that both are incorrect. So if I want to find the GPAs, so these are the GPAs, right? And my 2 Craigs have different GPAs. And for me to compute the GPA, the average GPA using this, it's going to be accurate. But if I use the join version, both with and without distinct, the GPA that I'm going to compute is inaccurate. Okay, so I guess I'm just saying all of that to show you that there are things that you can do with nested queries that are not always possible to do with joins. Yeah?
I mean, is there an issue if you just run the query as a previous example and ensure that you included the variable that would ensure you had distinct SID?
Here it would get rid of that problem. I can come up with more complex issues where that will not be possible. And essentially, let's think about what you want to return is just the aggregate average GPA. And you don't necessarily want to have that to be part of your query. And that aggregate will be wrong when you use the join rather than the nested version. Okay, so joins versus subqueries. Many nested queries are equivalent to simply queries using join operations. However, in many cases, the use of nested queries is necessary and cannot be replaced by join operations. Advantages of join queries. The join implementation can display data from old tables in the from clause, where the subquery implementation can only display data from the tables in the outer query. Right? So this is a big advantage on the join side. On the join side, when I've got from student and apply, in the select part, I can display attributes from both student and apply here. But I can only show things from the student side here in my outer query. Because this is inside my inner query, I can't show anything from apply here. Right? So that is an advantage for joins. Advantage of nested subqueries is that they have the ability to calculate an aggregated value on the fly and feed it back to the outer query for comparisons, which is an advantage subqueries have over joins. And in conclusion, you can use joins when you're displaying results from multiple tables, And you can often use subqueries when you need to compare aggregated values from different tables. Okay, division. Division in SQL is useful for answering queries, including for all or for every phrase. So far, we haven't talked about how you can find movie stars who were in all of the movies, right? And based on what you know so far, you would actually not be able to write that query. Unfortunately, there's no direct way to express division in SQL. We can write this query, but first, we would need to use double negation to write it, which becomes a pretty complicated query to write. But first of all, let's understand what division means. So division, often if you want to look at the query, you'll see that for all or for every happening as part of the query. And mathematically, this is what it would mean. So let's say I have a function, let's say I have a table A, where table A has two attributes. It has S number and P number. Right? And then I have another table B1, where B1 is sharing an attribute with A, P number, but it doesn't have the other one. Now, divisions can be extended beyond two attributes here and one attribute there, but they will become pretty complicated and out of the scope of this course. So in our divisions, we're mostly considering tables where you've got these two attributes on this side and you've got one shared attribute in your B side. So here I have S1, which is in relation with P1, P2, P3, P4, S2 with P1 and P2, S3 with P2, and S4 with P2 and P4. A divided by B1 means return things such that their S number is in relation with everything in B1. So I want to return things from A where it is in relation with everything in B1, which is just P2. So I'm returning things which are in relation with P2, which is what? Which is S1, S2, S3, and S4. So all of them are being returned. What do you expect to get from A divided by B2? S1 and S4. I want to return S's such that they're in relation with everything in B2. So they're in relation both with P2 and P4. So S1 is both in relation with P2 and P4, and S4 is in relation with both P2 and P4. You can see how I'm looking at the old thing. So if this is all the movies, so if B1 is your movies, and I'm looking for actors or actresses that have been in all movies, I'm dividing it by that, and it's returning things that are in relation with everything in that B movie, in that B relation. Right? So things in A that are in relation with everything in B. And that's giving me my all aspect that I'm looking for. And what do you expect A divided by B3? Just this one. So before we get to how you actually write this query, are we all on board on what division means? Because that's the first important part. All right, so let's see how we can write it. So essentially, I'm going to show you two ways to write SQL division. Neither of them are that easy. The first one uses two excepts. It uses a not exist and an except. So I want to find IDs of movie stars who have played in all of the movies. So I'm going to say select star ID from movie star where not exists. And my not exists is going to say return all the movies and then do except those that this person has played in. If the difference between all of the movies and those that this person has played in is nothing, then it means this person was in all of the movies. Right? That except says, here's all the movies. here are the movies in which this person played. If the difference is the empty set, then this person was in all the movies. So that says return them if the difference between all the movies and what they've been in is empty. And given that this is a correlated query again, essentially it's going to check that for each person, each movie star. It's going to do this comparison. What are all the movies? What are the movies this person has been in? If it's empty, they're in. If it's not empty, that means there are things that this person was not in. Therefore, they shouldn't be included in your final results. Does that make sense? So this is using where not exists. This gives you the all part. This gives you the thing which is related to this person. And then you're checking whether whether the outcome is the empty set or not.
If there are no such movie stars, will it return a relation with no rows?
It will return a relation with no rows, yes. So you're returning just the star ID, right? So it'd be one column, no 0 rows. Now, unfortunately, except is actually not implemented in MySQL, right? So this is great, but for your projects, you can't actually run this to do a all or a division query. So let's make it a bit more complicated. So this is a double negation, right? You want to find IDs of movies who have played in all of the movies. And essentially, this is what you want to do. So this is the black, red, and the green as you have here. You want to select movie stars from MS such that there's no movie M which is not played by MS. This is this is movie stars. So I've got two where not exist. I've moved away from using except, and I've got now two not where exists. So I've got the movie stars in MS such that there's no movie M which is not played by MS. Right? These are the movies played by MS. And you want to be such that does not exist anything here that this person has not played in. So, quick few facts. Division queries are important. They give you to ask questions like, how every or all things related to whatever domain you're working with. We talked about what they look like and what they mean. There's one way to write them using except, which is not going to be helpful for your projects. There's another way to use double negation with two nested queries to write them in MySQL so that you can run them in your projects as well. But this one needs a bit of thinking and it needs some practice as well. There are a few examples in the additional examples that I've added that you can also play around with.
Are we required in the project to, show a query where something appears in all?
I believe so. I give you a set of the types of queries that we want.
Yeah.
And one of the requirements is an all query.
Okay.
All right, let's take another break. Let's return and start at 2.